Alright, this is page 309, number 61. Question says, show that the given values of C are zeros of the polynomial and find the other zeros. So basically they're telling me that these are two zeros of the polynomial. Because this is a fourth degree polynomial, it should have 4 zeros, so asking us to find the other two. So we need to use the fact that these are zeros. If they're zeros, remember if x, I don't know why they say C. If x equals -2 is a 0, then x plus 2 is a factor. And if x equals 3 is a 0, then x minus 3 is a factor. So let's take those factors out. Since they're factors, when I take them out, my remainder should be 0. So I'm going to use synthetic division. 3, -8, -14, 31, and 6. And let's first take out the -2. It doesn't matter what order we take them out. So we'll bring down the 3, multiply, add, multiply, add, multiply, -28, add, +3, multiply, -6, remainder 0. It's not a coincidence that the remainder is 0 because they told us that this is supposed to be a 0. Alright, so now I have it down to, if I write it as in terms of the division algorithm, I got it written as x plus 2 times, and now I have 3x to the third minus 14x squared plus 14x plus 3. So I have this polynomial factored to that. Now let's take out the 3. Let's take out the x minus 3. But don't take it out of the original. I've got it broken down to this. So let's just take that x minus 3 out of that. Basically, let's just continue factoring further. Take out a 3. 3. Multiply, add. Multiply, add. Multiply. So again, I got a remainder of 0. Should not be a coincidence, right? And now I have my original polynomial broken down into an x plus 2 times an x minus 3 times a 3x squared minus 5x minus 1. And once I have this down to a quadratic, I should be able to factor using my old techniques, right? So x plus 2, x minus 3, 3x, x. So I'm looking for factors of -3 that, bummer. Unless I did something wrong, this is not factorable, right? So if this is not factorable, how do we find those last two zeros? Well, unfortunately, we have to set this 3x squared minus 5x minus 1 equal to 0 and solve it either using the either by completing the square or using the quadratic formula. Normally I like to complete the square, but you know, with a 3 and a 5 here, this one isn't real nice for completing the square. Screw it. I'm going to use completing the square anyway. I like completing the square better. 3x squared minus 5x equals 1. Divide by 3, divide by 3, divide by 3. X squared minus 5 thirds x equals 1/3. So I need to take -5 thirds and I need to half it and square it. So that would be 25 over 36. So I'm going to add 25 over 36. So this factors into x minus 5/6 squared. Multiply this by 12 over 12. So that is 25 plus 12 is 37/36. Square root both sides, plus minus. X minus 5/6 equals plus or minus the square root of 37 over 6. X equals 5 plus or minus the square root of 37 over 6. So those are my other two zeros. So in conclusion, sorry, it's a little bit small. Oh, can you see it? In conclusion, my zeros are the two that they gave me originally, x equals -2 and +3, and then 5 plus or minus the square root of 37 over 6. This polynomial has those 4 zeros. Okay? 2 of them I knew because they gave them to me. But once I knew those two, I was able to break down this polynomial into a quadratic and use my old techniques to find the last 2 zeros. Sorry guys, I should have done an example like this in class, but hopefully you guys were able to watch the video and figure it out.